Hey guys, welcome back. So in this video we are going to discuss about PL SQL. So PL SQL is nothing but a procedural language extension to SQL. So what is a procedural language and why is it being extended to SQL? So usually SQL is actually called as an imperative language. So by imperative we mean that so we only explain what has to be done but not how it should be done, right? So to give you an example, so we write a select star from tables. So we say, I want you to fetch all the records from this table, right? Uh, uh, in 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 this query, we're not actually uh, telling the system how to fetch the data. So we are just asking something to be done, right? So such kind of instructions we call them as imperative. So SQL is an imperative language. So we cannot write procedures in SQL. So we cannot kind of store whatever the query that we have written, and also we won't be able to kind of store the output as well, because whatever the output that the SQL query returns is just a temporary table. It will which will be provided to us. So SQL alone is not enough as a DB programmer to kind of do some sort of application management on a single DBMS server. So if we wanted to manage things on a system, so since we call it as DBMs, right? So it has to allow the developers to sort of manage some things on the system, right? So they have introduced a new thing called as PL SQL. So it might differ in other DBs. So we might call it as PL SQL. We call it as PL PGSQL, and we can call it as TSQL in some other. So it's nothing but so they expand the functionality of SQL, and they allow you to write some sort of objects. So okay, we will see see we will actually look into what all those features which will be provided to us. So in some way this PL SQL thing is going to allow us to sort of manage a lot of things without without explicit a need for any programming language. Okay, so coming to programming language, so as we had discussed that we wanted to run some sort of function, we wanted some output. Okay, we want to process the output, so we want to do something with the output of an SQL query. Then why can't I use just any other application programming language and use an API to connect with the database and then do whatever I want to do? So it is possible. In fact, the PL SQL can be uh, done using any programming language. Then why is it needed? Then why we are learning about it, and why does it still exist if uh, if 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 all the programming languages are there? So it is going to be our first discussion. So we're going to see why programming logic is needed on DBM. So we have discussed that to kind of process the output of a SQL query, and to make the query run multiple times, to sort of store the query, to sort of store the query output, to kind of make some sort of business logic on the data. So to do all these things, we need some sort of programming language on the DBMS. And then why not use any programming APIs? So for this, we have three answers. As the first one says is performance. So why is the performance of PL SQL is better than any programming language? Because programming languages are are more sophisticated, they are more robust, right? But the actual thing is, in reality, so all this data, it resides in a server, right? It resides in a DB server, and the client usually who has all these application programs is a machine in a network, and this a DB server is another machine in the network, right? So usually for the application programmers to do some to do some sort of functionality on the data, they have to use a network. So they have to connect to the database, and some sort of a management has to be done, and then it will be given the access, and so all these things have to happen. Okay, it will happen eventually, but to actually maintain a network is actually not an easy thing, because you have to make a lot of IO calls. There will be a lot of networking, a lot of routing has to be done, and throughout this interaction, the network has to be up. It cannot, if it gets terminated in between, so all of this might be lost, and we might have to redo everything that we had done. So so if so we have seen all these things, right? So instead of completely depending on an external API, we can run some sort of functions itself on this our database, so that the application can execute this function as a remote client, but still all these functions will be executed, and whatever the compiled code is there, it will be running on the same TB server. So it is going to improve the performance by a lot, because there won't be any context switching, and there won't be any network calls, and there won't be any overhead, right? So the entire performance will eventually be improved. And the second one is the security. Okay, how security is provided by these things. Okay, so here I stated, okay, in this diagram we see something called as a stored procedure. We'll see what a stored procedure is, but to actually give a brief overview of it, it's nothing but a function. It's a database function with its own syntax. uh, so it can execute some sequence of steps, right? So okay, so what can be those sequence of steps? It's usually any SQL query, any a DML queries, and maybe something. But okay, let's see how the security is provided. So here the application programmers, so they are requesting some sort of data. So usually, if we don't have anything like a stored procedure, we have to allow all these programs to access all the tables. So we have to give them a copy of the tables, which might be a security a vulnerability, because we don't want the entire code base to be. I mean, we don't want our uh, data to be visible to every client. So but if you're not exposing the data, then the application program won't be able to access data and run some functions, right? So it cannot happen. So in between, if we can write something called as a stored procedure, which is actually a function which we can write in any application. If we can write this function, and we can expose this, then we okay, then we can manage whatever the security that we needed just in this entire block, instead of assuming that okay, this application is going to use the table in the right way. Okay, there is no guarantee. If you are giving the data, so there is no guarantee that the application could actually use it for any malicious activity. But if you're giving them a procedure or any database object of the PL SQL, then it can only call the procedure, and the procedure is going to run whatever the statements that were given by us, right? So there won't be any security issue. So whatever the hidden content, so it will be hidden within the system, right? So this is one of the advantage, and obviously the last one is the reusability. So in application programs, the functions after okay once they are compiled, we can run them anywhere, right? Because the executable will be created. In the same way, all these PL SQL blocks, when they are executed at once, so when they're executed, its compiled version gets stored in the system. So whenever there is another call, we can simply execute whatever the pre-compiled block of statements that we have with us. So it is a great boost of, and since it promotes a reusability, so it makes sure that there might be any number of clients, still we're just executing the same compiled code. So it is providing you that a reusability factor, right? Okay, now let's go into the actual topic. Let's see what are these stored as sub programs are. So As you might know, a subprogram is any program which can be called by another program. So as a stored, so we are calling it as a subprogram because once written, it will be compiled, and you can only so you can so whenever you try to call that procedure or a function or a subprogram, so only the compiled version will be executed. So that's why they have named it as a stored subprogram. So these are of two types. So not actual types. These are actually of two variations, I would say, because so they actually do the same thing. So one of them is the stored procedure, and the other is the stored functions. So a procedure and function are very identical except a few things. Uh, so if you look at this, so a producer, so we use, oh sorry, for the procedure we use this keyword called procedure, and for function we use the keyword function. So one of the major difference is that a procedure is not supposed to written anything. Okay, we have something called as an out parameter, but again, a procedure is not supposed to written anything. It is only supposed to run some sort of steps. But a function will have a written type. It can written something. It can do processing and it can written. And the okay, the rest is same, but the way we can call a function and the way we call a procedure is going to be a bit different because for executing a procedure we can use a few keywords. We can use execute keyword and we can use the call. So one of them might work because there is an ANSI SQL syntax and some other a database specific syntax as well. Okay, and to actually call a function, we don't need any of this. We can just select that function name. Great. So how can we select the function name? So I can say select f, right? So this is the way we can call a function. I hope you can understand this, that we have seen something of this sort, right? We have seen a Windows function. We have seen like the max, a min. So all of these are actually functions. So we can use them in a select statement as well. So I think these are the a small variations between a procedure and a function. But whatever the statement that we write, so any statement which can be a procedure, it can also be a function, right? Now let's look at a stored procedure, right? So let's see how it works. Okay, an application. So if if you're not if you're not using any sort of stored procedure. Okay, so we have just created one. The application program is going to ask for some resource. Okay, some stored. Okay, the SQL query will be redirected. So this procedure is going to run, and it will be stored in the DB, right? So a task will be written. Okay, if this thing happens for multiple times, right? So there will be some variation. So whenever we try to call a procedure again, it will be stored. So it is going to do the manipulation directly by following the instructions, and it is going to return back. So this way, only when the stored procedure is not compiled, it is going to compile, and then for every other request, we are going to execute it directly, right? And then okay, so that's mostly about the procedures, and so we'll see how they work in another practical session. Now let's look at another database objects. It is called as cursors. A cursor, right? So if we were to see it from a developer's point of view, a cursor is nothing but it is nothing but a record pointer which will be pointing to a record that we are processing currently. But okay, but a database might have another view. A cursor is in a uh, database is actually defined as the active set, right? So what is an active set? So active set is actually what we are working on right now. So whatever the tables or the resources that we are uh, currently working on can be called as a cursor, right? So it's normally a table. So using this cursors, so we will be able to access the records of the data. whatever we have asked, right? So then why do we need to have a cursor? So it is actually that we have two sort of cursors. We have implicit cursors and explicit cursors. So for any query, if we were to do any manipulation or we were to do anything on the data, if on a specific relation or a table, then we have to fetch it from the secondary memory. So whenever we fetch it from the memory and keep it in our temporary buffer, it is nothing but our active set. So that active set will have an implicit cursor. Implicit cursors will be maintained by the database, but if we were to do some sort of a manipulation even before the row is fetched, okay, so it's not like that we are only trying to use an SQL query, but we wanted to do something more than a, okay, so if we were to do something more than an SQL query, then we need to access whatever the internal mechanism that is actually executing the query. So that internal mechanism is the cursor, right? So if it is implicitly created, then how can a developer be able to access it and make changes to the way it is operated? So that's why they have provided the explicit cursors. So using explicit cursors, we can do our own operations. We can make the cursor do whatever we want to do instead of instead of doing what is defined by the SQL query, right? Okay, this is the cursor function. So this is called as an active set. So as we have defined, so this is the current row. We usually think that this is actually what is called as a cursor, but no, this entire row, this entire active set is actually considered as a cursor because that is the active set that we are working on, right? So a cursor, okay, it will also have an internal pointer which will be pointing to the current record, and when this record is processed, we will move on to the next one. So this is how they work implicitly. But if we were to explicitly change the way we are, we can declare our own cursors. So this is the syntax how it works. Okay, so we need to use the declare statement and we need to say cursor. It's a keyword, and this is the name of our cursor. And after writing all the name of the cursors, we need to provide a statement, a select statement, which is normally a command. So this is what normally done. So if we were to only write this whole portion, an implicit cursor will be created and something will be happening, which will be managed by the DP. But here, since we are trying to operate on our own, we are going to define our own cursor, okay, and then we'll say begin, and we will open the cursor. Okay, in the left you can see what happens. So when we declare a cursor, a name of okay, a named SQL array will be created for which an active set, when it appears, it is going to execute. So so we're only declaring, we're not actually fetching any data. And then we say open. So when we say open, whatever the statement that we have given in this cursor, it will be used to identify the resource, and all the planning for that will be done, right? And then we say fetch, and then we say fetch current department into. Okay, into is a new keyword. It is used to insert values into okay, if we want to insert values not into a table but into some sort of variables, then we can use into along with fetch. If we say fetch something into vid and vname, so vid and vname are two variables that we have defined here, right? So we have defined two variables here. So into this variable, I am going to put whatever the output that is given by our current department cursor, and then I'm going to exit. So actually this is one of the most important things. So when is supposed to exit? So we will be using a loop because whatever the output that is being pointed by the cursor is usually not a single record. It's usually a lot of records. So we have to use a loop to actually a loop through all of them. But when are you supposed to stop? You are supposed to exit when a record is not found. Okay, or in PL SQL we say exit when not found. Okay, when anything is not found, when you're not finding anything, then you can exit. Okay, and after exiting, you're supposed to close the cursor as well, as it's a good practice. Okay, so this is how we declare a cursor, and this is how it works. Okay, when you fetch, it is gonna check if it is empty. Okay, if it's not empty, then you're gonna fetch another record. Okay, this happens until and when it becomes empty, we're going to exit from the loop and we're going to close the cursor. So this is how the cursors works. So these are used to do some a specific task. If it cannot be achieved with a simple SQL query, with a simple select query, we are going to use the cursors to explicitly access the record and do something on that record, right? So that's all about the cursors, I think. And let's see the flow of the cursor. Okay, here we have to declare the variables and the cursor, and then we have to open the cursor and then fetch the next 20 variables and print the current value, or you can do whatever the processing that you want. And then you do it till it is returning something. But when it is returning anything not found, then you're going to exit the okay then you're going to exit that loop and you're going to close the cursor, and then it will deallocate the cursor. So a cursor is a memory, right? So it has to be deallocated such that any others can use it. If not, if you're not closing it, so there is no explicit garbage collection sort of thing in DBMS. We have to close it ourselves. If not, then it will lead us to some sort of a memory leaks, which is not ideal, right? Okay, so that's all about cursors. I think you have understood why they are needed. But now we are going to an important topic, because this is where I think as an application programmer we are going to use any sort of PL SQL things. Then it is either mostly a procedure with a trigger, a procedure with a trigger, or a procedure with a cursor, right? So triggers. Okay, let's see about triggers. So what are triggers? So triggers are defined as an automatically callable sequence of code on when some event happens, right? So as the name suggests, it will be okay. Some statements will be triggered automatically for some event. See, in the case of a procedure, we have to explicitly call the procedure. We have to explicitly say that okay, I need you to be executed. Then uh, if only someone is actually making a call to the procedure, it will be executed. If not, it will stay as it is. But if we want to automate the calling of a procedure, right? If okay, I want to say, for some event, this procedure has to work. Okay, I mean, it has to be implicitly called. Okay, then how can I achieve such a functionality? Is there a way? Yes, a trigger is actually one of the way that you can do that. A trigger will have some sort of steps which will be automatically executed, because you don't have to explicitly call a trigger. You can only create a trigger and you cannot call a trigger. It will be automatically called. If whatever the event that you think is going to trigger this, if it never occurs, a trigger will never be called, right? So that's how its a functionality is defined. Let's see how it actually looks like. Okay, on a table, actual triggers are defined on a table, right? When an application tries to do something on the table, so usually any DML operation, we can write triggers on that operation, right? If an application is trying to insert some data into the trigger, then we can write an insert trigger. This will be triggered as and when anything is being inserted into the table. And this insert triggers can be of two types. It can be an after trigger, it can be a before trigger. What is this after trigger and what is this before trigger? So you can define if you want these statements to execute after the instruction has happened, or before the instruction has happened, right? So we will see with a practical example how it actually differs, right? And we'll say about something called as a magic tables. We'll see it later. So I think you have understood that okay, if if you're doing an insert operation or update operation or any delete operation, if there is some a trigger provided in the DB, that trigger will be fired up because of that event, right? Now let's see the now let's see the a syntax of creating a trigger. So we use create trigger name. Okay, this is the trigger name, and here we said before, right? I said before, so this will be a before insert trigger. That means if I'm inserting into this table called my table, before inserting the records, okay, before inserting the records, this trigger will be fired and it is going to execute some function. It is going to execute a function. So it is going to execute this function called my function, or you can say it can also be a procedure for each row. So this is sort of important because a triggers are usually defined in two other ways. So we can say a trigger can be a row level trigger or a statement level trigger. A statement level trigger is just like an insert statement. Okay, I'm inserting, you get triggered on this table. But if you're updating this specific record, even then I want it to be triggered. So you can define it in a way that it should work for each row, right? So this is how it works, and whatever this function is there, okay, whatever the code is inside this function, it will be executed by the trigger for once, okay, and again it will only run for once for a one event, okay, and then okay, then we'll see what these magic tables are about. Okay, okay, yeah, magic tables. So if you're using a, mm, as we discussed, uh, a trigger can be an after trigger or a before trigger, right? So but okay, if I have inserted something in the into a table, then there is a something okay, there will be a some certain okay, a some set of records after insert and a some set of records before inserting. So if I want to so if I want to access the table before it was updated, okay, how can I access the table? So we cannot. But if you're specifically using the after or before triggers, our DB is going to provide a special service called as a magic tables. What are these magic tables? So you have this table, right? So you're saying insert something. Okay, so you're using the insert command. So you have inserted some 20 records. So initially it had like 10 records, and you have inserted some 20 records. Then there will be a replicas created. One of them will be called as old, and one of them is called as new. So this new will be having all this updated records of 30, and the old will still have this 10 records. So you can use this to compare how many, whatever the operation has happened. So using so these magic tables are only formed when you're using a trigger which is specifically an event trigger, like before and after. So this will be only created in such a cases. And there is also another kind of trigger called as instead of trigger. So instead of trigger is used when, okay, when you uh, don't want the original operation to be done, instead of you are trying to do whatever the trigger says. So it is also a way you can program, right? So I think that's the end of it. So I think uh, this video was an important one because PL SQL might not be used heavily by us as a application programmers, but still it is needed to understand that why it is needed. So it is going to be very important in a production, as whoever the team who works on the DB. So they are going to write some sort of procedures, and there will be some sort of triggers. So we should know how to access them, and we should know how to call them. Triggers we cannot call them. So all these are just so these three are the major database objects, the procedures, triggers, functions, and cursors. So we should be able to know how to call them. So procedures are called, by the way, as a so as we are discussing, and triggers are automatically called. So this is how the PL SQL provides some sort of functionality over the SQL queries. So it is it makes a database system a manageable system. So if you only have a DBMS software, you can eventually manage your entire business. I mean, not your entire business. If it is a small scale business, it can be managed, because now you can write queries and you can use some sort of programming a logic on them. So that makes it a complete application, right? So this is actually our last lecture on a DBMS. From next video, I'm actually going to do a little bit of a practical on this. So that's going to be our next video, and see you in that video then. Bye.